Hi, welcome to my channel FRM Unplugged. We will be today continuing with our mathematical concept discussion. So these mathematical concepts, or rather statistical concepts that we are doing is just not, it's not a standalone kind of a thing that we are doing just for the sake of it. This has application across risk, finance, statistics, even mathematics. So today we will be delving on the ways of counting, which is permutations and combinations. Like once we kind of progress into this session, we will see how this is linked to the global financial crisis, which was kind of a life-changing experience that happened in 2008. Apart from this, there is extensive usage of permutations and combinations in, I think you guessed it correctly, in probability as well as in other distributions like binomials. So it is imperative that we have a reasonably good idea of the logic behind it, even though we are not expected to get into very nitty-gritties and very complex problems, but we should have a clear understanding. We will straight away get into first the basics of counting. Okay, so now if there are, let us say, 5 people, okay, A to E, if we are asked to arrange them in this line, in how many ways can we arrange A to E? 5 people. So A will be arranged in how many ways? There are 5 seats for A. So A can occupy any of the 5 seats. So there are 5 ways for A. Similarly for B also, there are how many seats? 5? No, it's not 5, it is 4, because 1 is already taken up by A. Similarly, C is how much? 2 are taken up by A and B, so C is only left with 3. Similarly, D is 2 and E doesn't have a choice. A, B, C, D is already taken, so E doesn't have a choice. It has to take the only lone seat that is vacant, so E will have 1 way. So the total number of ways in which they can be arranged is 5 into 4 into 3 into 2 into 1 is how many? 120. Now this is the fundamental principle of counting. So assume there are 3 cities A, B, C. If there is 3 ways to go from A to B, and if there is 5 ways to go from B to C, right? So there are total, for every route from A to B, there are 5 routes from B to C. So total number of way to go from A to C is 15. The same logic is getting applied here. Because counting is like repeated addition. And what is repeated addition? That is multiplication. So that is how we have. Now this term, there is a special mathematical operator. Plus, minus, in the terminology of software, these are called operators. So here this is called factorial 5. Factorial is a mathematical operator which multiplies the number with all its preceding numbers till 1. It only takes the whole numbers, it doesn't take the fraction or decimal. So factorial 7 means 7 into 6 into 5 into ... 3, 2, 1. And this is the symbol for factorial. Few books, few literature you will find like this, 7 factorial. Factorial is also written this way, but in common terminology it's written in this exclamation mark. So let us go by this logic. Now let us go one step ahead now. Since we know the basics of counting, now if we are given another problem, okay, there are 5 vowels, A, E, I, O, U. Tell me the number of ways in which 3 words can be formed by taking 3 letters, right? Which means, let's say, for example, if I take I, O, U, I will have I, O, U as one word, U, O, I as one word, U, I, O as another word, O, I, U is so like this. So here, not only we are selecting, but we are also arranging, right? So the number of ways in which 3 words can be formed from this 5 vowels is what is called 5p3. And the formula is, factorial 5 by 5 minus 3 factorial. This is the formula for 5p3. This essentially gives us the number of ways in which three letters can be chosen from AIOU, and once it is chosen, they are also arranged. So three words can be arranged within themselves, three letters can be arranged within themselves in factorial. So that entire stuff is captured here in 5p3. Now if I were to just ask that, okay, how many ways can just three letters be taken from this 5 letters? Then the answer is 5c3, which is factorial 5. Sorry, I am using that other symbol. Factorial 5 by factorial 3 into factorial 5 minus 3. Okay. So obviously from our common sense also we can say that the combination is supposed to be numerically less than the permutation, simply because combination is just we are selecting, we are not arranging. Whenever we are selecting as well as arranging, it is permutation and it is higher, right? So in our first one where A, B, C, D, E, we are finding out the ways, there it is neither permutation nor combination, because we are already given 5 letters. We just have to find out the ways in which it can be arranged, which is factorial 5. The one that we did earlier. That did not require permutation. See, permutation has selection plus combination. Permutation has selection plus arrangement. Combination has selection. That problem only required arrangement. Got that difference? So first one was only arrangement, combination is only selection, and permutation is selection plus arrangement. So with this we can get into the questions, into the other questions. So just keep this in mind. Again, like I have mentioned earlier, so these kind of standalone questions are not going to come. This is just given so that you are more thorough with your understanding. That's all. Okay. So how many 3-letter words can be formed using the letters from the word fable? So 5 letters are there. We have to form 3 letters, right? Which 3-letter word. So again, this is 5p3 like we did earlier. Similarly, this one, a committee of 5 members is to be formed from a group of 10 people. In how many ways can this be done? This is obviously 10c5, because we are only bothered with selecting. We don't want any arrangement. We just want the committee members, right? So in how many ways can we? So there could be this many number of ways we can have 5 people. One is maybe, let's say 1, 2, 3, 8, 9, then 10, 4, 5, 1, 2. Like that we will just have a group. That's all. We don't give any importance to the to the way they are arranged. Now this question is slightly different. So out of 6 consonants and 3 vowels, how many expressions of 2 consonants and 1 vowel can be formed? So 2 consonant and 1 vowel. So answer is what? 6c2 into 3c1. This is the answer? No, this is not the full answer. We still have to, there is one small piece that we have left out, which is, okay, we selected 2 consonant from the 6, we selected 1 vowel from the 3 and we multiplied. But then again, those 2 consonant and 1 vowel that we selected, they also need to be arranged within themselves in how many ways? Factorial 3. So we will have to multiply it by factor. So why are we multiplying? The same like we discussed the principle of counting. So this way we can find out the answer. Now sometimes we may, in some of the covariance or some numericals related to market risk, there may be some this kind of calculations required, but it is very unlikely it will formed as a standalone question. You need to calculate this, and then this can be an intermediate step. So this will be used in some problem, maybe. So it's important we keep this in mind. Obviously, and apart from this, the probability is very direct, right? These have extensive usage in probability. So I am not discussing probability at all, because probability this is the heart and soul, the backbone of probability. Okay. Now the final one, right? There are how many 4-digit pin codes can be created using the digits 0 to 9 if repetition is allowed. Okay. So 1, 2, 3, 4. So repetition is allowed, which means same number can happen in four places. So 10, can be filled up in 10 ways, this can be filled up in 10 ways, this in 10, this in 10. So once we multiply it, this is the answer. Is this the answer? No, this is not the answer. The answer is, see, here it can't be 10, because you can't have a 0 here, right? Otherwise it becomes a 3-digit number. So this place only can be filled up in 9 ways, whereas these all are okay. This can be 10, because there is no condition of that numbers won't be repeated. It said repetition is allowed. So 9,000. Total is 9,000 ways. So with this, we completed some of the numericals on permutations, combinations. Like this will be extensively used in probability, and the probability we will take up separately. So today in this session, what I want to highlight is the usage of mathematical operators on the global financial crisis. Now, this is not to oversimplify global financial crisis. It was caused by a myriad of factors, and a multitude of factors were at play in correlation, banks' aggressiveness, government policy. But just keep this in mind, how one of the things that got missed out by the risk managers, which involved the combination. So for the global financial crisis, there was one product called CDO, which is collateralized debt obligation. So for now, we will discuss again CDO separately, but for now, know that the CDO is a structured product which the banks used to create by hiving off the loans from their balance sheet into a separately spun special purpose vehicle, SPV. So CDO had basket of loans. Okay, so it had maybe 1 2-year loan, one 4-year vehicle loan, 1 year credit card, 30-year mortgage, everything it had, right? And so look at it this way: if I am an employee of Castrol is a leading lubricant company, and if I am taking a loan from, let's say, some bank, there is a bank will assess the probability of default of me. Let's say it is 5%. Now, if the bank knows that there are 10 other people from Castrol only who has defaulted already, and when they are assessing my case, then will the probability of default be 5%? No, it will be somewhat more, right? Because there is a correlation. Similarly, if there is other companies, let's say from who has taken loan from the same bank, let's say employee of Tata Motors who has taken loan, they have also defaulted, then my default of probability will not be 5%, it will be 6%, right? So that way there is a correlation. So other activities are impacting the probability of my default. This is the correlation, and so correlation is always taken 2 at a time, let's say, to study. So the risk managers ought to have done, what they ought to have done is for them to study the correlation between those loan which was there in the CDO basket. For one CDO basket, there were 125 products. And this kind of 2-year loan, 2.5-year vehicle loan, 3-year some personal loan, 20-year mortgage loan, all those. So if I have to select 2 from 125, I will do it in 125C2 is equal to 125 into 124 by, okay, let's do it this way, 123 factorial by factorial 2 by factorial 123, right? So this and this gets cancelled, and this is 62. So 125 into 62 is close to 7,500. I mean, more than 7,000. So the risk managers ought to have studied and found out the correlation figures for 7,500 positions within one CDO. So we see, hindsighting is easy. It is very easy to do some hindsighting exercise and come to conclusion, okay, this was this was that, so this happened due to that. So, but if we have to make a reasonable surmise, we can always surmise that this 7,500 positions, finding out the correlation, though this could have been done by a software also. It is not that the risk manager would have to manually do some calculation. But even then, they either by mistake they missed it, or maybe due to paucity of time, or they were under pressure to jack up the profits of the bank. Whatever be the case, they missed out this. Finding out the 7,500 positions, finding out that there 7,500 positions exist within this CDOs whose correlation was required. So here we find one direct application of the ways of counting. So obviously this was missed, and eventually what happened was, let's say everything was like the sea was calm, right? But once 1 2-year loan got defaulted, this affected another 3-year loan. The 3-year loan affected another 1-year loan. Eventually entire basket defaulted. So this was something which was missed out. Maybe if the risk managers would have done this calculation, it may have helped. They may have caught it during their covenant monitoring exercise. So with this, we kind of complete the session on permutations and combinations. I believe whatever I have discussed, if we are able to have a handle on this, this is more than sufficient for our exam purpose, as well as dealing with situations in our work life as a risk manager. So in case you have any queries, you are welcome to reach out to me through my YouTube channel comment section, and I would thank you for your time and attention. We will shortly be coming up with some other videos on the mathematical concepts. Thank you.